Good morning, students. Myself Ritu Randev, PGT Computer Science, Kendriya Vidyalaya, Muradabad. Today we are going to learn about Boolean algebra. We have already learned the concept of computer system memory, computer organization, and types of software. Today we will see what is Boolean algebra. In Boolean algebra, we see that there are different types of gates, the principles, the postulates, and the De Morgan's theorem. As we know that Boolean algebra was introduced by a great mathematician George Boole, and he demonstrated the properties of switching the circuits by representing the algebra in the form of the circuits, that is 0 and 1. So Boolean algebra is an algebraic system which consists of the set 0 and 1, that is the binary operations, or and. Or is represented by plus and is denoted by dot sign. Whereas the not operator is represented by a bar or a tilde sign or a prime, we say. So these three things, and, or, not, all these operators we will learn in the form of the different logic gates and form the different logic circuits. So the logical operators, the three logical operators, and, or, not. And means conjunction, disjunction is or operation, and not operation is the negation operation. And they are represented using a truth table. All the possible input combination of the logical variables along with all the possible results are given in the form of a table that is called as a truth table. Now these logic circuits are the building block of any system. Whenever we show the electronic circuit, they are in the form of one input, one output. The relationship between the input and the output is based on a certain logic, and these logics are then called as logic gates. And these three gates are AND gate, OR gate, NOT gate. We can see it in the form of the truth table, the circuit also, that the operator AND, which is also called as the logical multiplication, is denoted by dot sign, and here it has some properties of 0 and 1. 0 and 0 makes 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. So the two inputs x and y. We can see the pattern, the combination of the input 0, 0, 1, 1 for the x variable, 0, 1, 0, 1 for the y variable. And then we can see the resultant variable on the basis of the working of the AND operator. OR operator means which is denoted by plus symbol, also called as logical addition. The gate of the OR operator is in the form of slight curve or in gate we say, and 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is 1. NOT operator is simply the complementation operator. Negation of 0 is 1 and 1 negation is 0, and it is represented in the form of a triangle, inverted triangle. So x is 0 if its complement will be x bar. If x is 1, its complement will be 0. Before going to the different theorems, we will see what are the basic postulates of the Boolean algebra. The Boolean algebra consists of the fundamental laws. They are used to build some framework, and the basic postulates of Boolean algebra are: first is, if x not equal to 0 then x will be 1, if x not equal to 1 then x will be 0. Or relation is, we have just seen 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is 1. And relation 0 dot 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, 1 dot 1 is 1. Not relation 0 not 0 is 1 and 1 not 1 is 0. What is the principle of duality? The principle of duality says that in a given expression, in a given relation, change every sign. Suppose the sign is plus, change the sign to sign and sign to the or sign. Replace each 0 by 1 and each 1 by 0. Say for example, if x dot y is 1, then its dual will be x plus 0 is equal x plus y is equal to 0, because dot has been replaced by plus and 1 is replaced by 0. And so duality means that the derived relation using duality principle is called dual of original expression. Now, since we know the basics of the Boolean algebra, the types of the circuit, the gates, the operators, now we will see the basic theorem of the Boolean algebra. The properties of 0 and 1 are 0 plus x is x, 1 plus x is 1, 0 dot x is 0 and 1 dot x is x. We have to keep all these in mind because we will further see the different theorems on Boolean algebra. First law is independence law. This law states that x plus x is equal to x and x dot x is equal to x. So you can see x plus x is x, that is 0 plus 0 is 0, 1 plus 1 is 1. And another law of independence is x dot x is equal to x, 0 dot 0 is equal to 0, 1 dot 1 is equal to 1. The involution law is x bar, the whole bar is equal to x. Means negation of x will be x and again the negation of x will be x. So this is the simple law, involution law. Very important is the complementarity law. X plus x bar is equal to 1. We see the input x and its negation x bar will be 1. And we can draw it in the form of the truth table also. Because x is 0 and then x is 1 and x0 will be, its negation will be 1 and 1's negation will be 0. So 0 plus 1 will be 1, 1 plus 0 will be 1. X dot x bar is equal to 0. So x is 0 and 1. So 0 becomes 1, 1 becomes 0. And this we can represent in the form of the logic gate also. Commutative law says that the two sides x plus y LHS is equal to y plus x, that is RHS. And we can see here from the truth table that x plus y is equal to y plus x. So the two patterns, the two combinations x and y we will take. The two patterns x will be 0, 0, 1, 1, y will be 0, 1, 0, 1. Commutative law second says that x and y is equal to y dot x. Again, x dot y will have all zeros and then 1 and y dot x will have all zeros and then 1. So this is commutative law, second law. Associative law. We always get to draw a truth table of this law. This is an important law. Associative law is x plus y plus z is equal to x plus y, the bracket plus z. Now, since there are three inputs, we can see there are three inputs x, y and z. So, the combination will be 2 to power 3 is equal to 8. We will have 4 rows. So, 4 zeros, 4 1, 2 zeros, 2 1, 2 0, 2 1, 0 1, 0 1, 0 1, 0 1, 0 1. Now, what we see that when we draw the truth table, we will first evaluate y plus z, then we will see x plus y, then the expression, this expression of LHS and then the expression of RHS. And in the last we will see that LHS is equal to RHS. Associative law second, in which plus operator is replaced by dot, that is and. X, Y, Z, again we will take the three inputs and then evaluate the expression. And one side we will get all zeros and then 1 and the RHS will be also the same as the LHS. So how to draw the truth table? Firstly we will take the three inputs x, y, z. Then we will see these expressions y, z, x, y. Then r is equal to x, y, z and r is equal to x into y and into z. Distributive law, the seventh law is distributive law. The first distributive law is x into y plus z is equal to xy plus xz. Now, we see the gates are also very important. Sometimes we get in the question to draw the distributive law circuit also, and sometimes the truth table also. So, x into y plus z is equal to x into y plus xz. So, the three inputs again we are having. We see that here are the three inputs x, y, z. xy plus xz. Again we will form all the bit combinations and then evaluate individual expression, and then we see that LHS is equals to RHS. The second distributive law, which is solved by the mathematical or the algebraic method, is that RHS. We take RHS. What is RHS? RHS is x plus y into x plus z. Now, when we take x plus y into x plus z, what we will see? We will apply the distributive law. Distributive law we have just seen. Here it is. And then what we will see? What we take? We take x as a common factor and x plus z plus y into x plus z. Then x into x we take here and x into z will be plus. And plus is what? X into y plus yz. Then we will apply the properties of 0 and 1. X plus xz plus xy plus yz. Here we take x common and then we apply the property of 0 and 1, that is x is equal to x dot 1. So we here see x is equals to x dot 1 plus xz plus xy plus yz. Again we will take x common and then 1 plus z plus y plus yz. And again we are applying the properties of 0 and 1. X dot y plus yz is equal to x plus yz, and which says that x plus yz, that is LHS, is equal to RHS. Hence it is proved here by the algebraic method. And third distributive law is x plus x bar y is equal to x plus y. Again we will prove it by the algebraic method. LHS we see that it is x plus x bar y. So x is the common factor. So properties of 0 and 1 are applied. So x into x is equal to x into 1. So x is equal to x into 1 plus x bar y. We will just write it as it is. Then we will take x common, 1 plus y. We will take y here and x bar y is multiplied here. And then we see x plus xy plus x bar y. Complementarity law apply this. X plus y into x plus x bar. Since the properties of 0 and 1, we know that y dot 1. X plus y dot 1. X plus x bar is 1. So it becomes y dot 1 is equal to x plus y, which is proved by RHS. Then comes the absorption law. Absorption law, first law is x is equal to x plus y. X plus y is equal to x. Again, we can see there are the two inputs x and y, and LHS is equals to x plus xy. So we take the common factor x, and then we know that properties of 0 and 1, that that y is equal to 1 plus y. So we will take y is 1 plus y, and this x dot y is equal to x and 1 plus y is 1. So x dot 1 is equal to x. So hence it is proved. Absorption law second says that x into x plus y is equal to x. So distributive law will be applied here. Idempotence law is applied here. So x into x plus y. So x into x plus x into y. So x into x makes it x and plus x dot y. Since we know from the properties of 0 and 1 that 1 plus y is equal to 1. So x plus x becomes x and 1 plus y becomes 1. So x into 1 is x. Hence it is proved that x into x plus y is equal to x. The very important is the De Morgan's theorem. In De Morgan's theorem, the first theorem is x plus y the whole bar is equal to x bar dot y bar. Its truth table is important. Its circuit is also very important. In this De Morgan's theorem, we assume that P is equal to x plus y. P is equal to x plus y. The whole term x plus y is assumed to be P, where P, x, y are the logical variables. Then according to the complementarity law, P plus P bar is equal to 1 and P dot P bar is equal to 0. So if P is equal to x plus y, then P bar is equal to x bar y bar. So P plus P bar becomes x plus y because P is equal to x plus y plus x bar y bar, which must be equal to 1. And P dot P bar is equal to x plus y dot x bar y bar must be equal to 0. So we can prove it now. See the proof. The first part of the first theorem. X plus y plus x bar y bar is equal to 1. Here we will apply the distributive law. So x plus y plus x bar y bar. It becomes x plus y plus x bar dot x plus y plus y bar. Complementarity law is applied now. Since we know x plus x bar is equal to 1, so x bar term becomes 1 plus y into x plus y plus y bar. So x plus 1, applying the properties of 0 and 1. Then properties of 0 and 1. 1 and 1 makes it 1. So here we see that we have proved that x plus y plus x bar y bar is equal to 1. Now the second part of the first theorem is x plus y into x bar y bar is equal to 0. So x plus y into x bar y bar. Then here we are applying the distributive law. The distributive law is a plus b into c is equal to a into c plus a into b. So we are applying the distributive law here. So x plus y into x bar y bar. So x into x bar y bar plus xy bar into y bar, where again we are applying the associative law. Associative law says that x dot y is equal to y dot x. So complementarity law, x bar y bar plus x bar and y bar. So x bar is equal to 0. So this term x bar becomes 0. 0 into y bar plus x bar into y bar becomes 0. So y bar plus x bar becomes 0 plus 0 is 0. So this is how we have proved the first De Morgan's law and its second part. Since another second algorithm of theorem of De Morgan's is x dot y bar is equal to x bar plus y bar. Again we assume that P is a term which is x dot y, where p, x, y are logical variables. And according to the complementarity law, p dot p bar is equal to 1 and p dot p bar is equal to 0. If p is equal to x dot y, then p bar will be x bar plus y bar. So we have to prove that p plus p bar is equal to xy plus x bar plus y bar must be equal to 1 and p dot p bar is equal to xy dot x bar plus y bar must be equal to 0. So let us prove the first part of the second theorem, which is xy plus x bar plus y bar should be 1. Applying the distributive law, we see that x plus x bar plus y bar into y plus x bar plus y bar becomes this, and now we are applying the commutative law on it, then applying the properties of 0 and 1, and we see that finally we get 1 on the right side. So LHS is equal to RHS. So proving the second part of the second theorem, xy dot x bar plus y bar is equal to 0. So xy dot x bar plus y bar, applying the distributive law, the terms xy dot x bar plus xy dot y bar, applying the associative law. Then applying the complementarity law, x dot x bar is 0, 0 dot y plus x dot y bar is y dot y bar is 0. Again becomes x dot 0, properties of 0 and 1. So this 0 dot y is 0 plus x dot 0 is 0. 0 plus 0 is 0. Hence the second part is proved. We can go through the revision of all the Boolean algebraic rules. It is in the form of the table. Last minute revision tool for exam. It will be very helpful to you in the form of the table. So just make a chart of it and display it near your study table so that you come to revise it every time. And there are some more logical gates which are universal gates. They are NAND, NOR, XOR, XNOR. NAND gate is a universal gate which is a combination of AND with a NOT. We can see 2-input NAND gate, 3-input NAND gate and 4-input NAND gate. When it is 4-input NAND gate, the combinations are 16. 2 keep are 4. NOR gate is a universal gate which is a combination of OR with NOT. XOR gate produces the output 1 for only those input combination which have odd numbers of 1s. So we have certain questions also. We can take some examples to prove using the truth table, logic gates. We get the questions, we get the expression, and we are asked to draw the logic circuit, the logic gate. One thing we have to remember is we should understand what is the symbolic representation of AND or NOT, and then also try to understand how many inputs are required so that we write the proper combinations for the truth table. And second question we are asked is, we are given the circuit and we have to write the expression for the given circuit. So here are some more questions for practice. Hope you find the session interesting. Thanks for the patient listening. Thank you so much.